Hello, Mayank Agarwal here, and welcome to this deep dive into the fascinating world of process control. Today, we're diving into the world of processes, the backbone of any operation, big or small. We'll explore how understanding and managing these processes is crucial for achieving consistent results and maintaining high standards. We're talking about everything from making a sandwich, ensuring each one is as delicious as the last, to building rockets, where precision and reliability are not just desired, but absolutely essential for mission success. In science and engineering, we want our processes to be consistent and reliable. We need to be able to predict outcomes and minimize variations. This is where the power of process control truly shines. But how do we know if things are running smoothly, or if trouble is brewing? How can we proactively identify potential issues before they impact our final product or service? That's where control charts come in. They provide a visual representation of your process data over time, allowing you to quickly identify trends, patterns, and deviations from the norm. Think of a control chart as your data superhero, swooping in to save the day. It's like an early warning system, spotting problems before they get out of hand and helping you maintain optimal performance. We're not stopping at the basics. We're going beyond the fundamentals to explore the more sophisticated applications of control charts. We'll delve into advanced control charts, the tools experts use for complex situations, providing you with the knowledge to tackle even the most challenging process control scenarios. By the end, you'll know how to turn confusing numbers into clear visual stories, empowering you to make data-driven decisions and drive continuous improvement. Whether you're baking cookies, ensuring each batch is perfectly golden brown and delicious, or building medical devices, where patient safety and product efficacy are paramount, control charts help you see, understand, and improve. They provide the insights you need to optimize your processes and achieve your goals. Ready to unlock the secrets of pro-level control charts and take your process control skills to the next level? Let's get started. Science rules, and so does data-driven decision-making. What's a control chart and why should you care? In the world of data and processes, understanding variation is key. Control charts are powerful tools that help us distinguish between normal, expected fluctuations and those that signal a real problem. They provide a visual representation of process behavior over time, allowing us to monitor stability and identify areas for improvement. Imagine riding your bike. You wobble a bit, it's natural. You're making tiny adjustments to stay balanced. This constant minor fluctuation is part of the normal riding experience, but you still manage to stay on the path. The center line on a control chart is like your intended path on the bike. It represents the average or expected value of the process you're monitoring. It's the target you're aiming for, the ideal performance level. Now, the upper and lower control limits are like the boundaries of the road or guardrails. They define the range of acceptable variation. These limits are statistically calculated based on the inherent variability of the process itself. As long as you're between those lines, staying within the control limits, everything's considered normal. The process is stable and predictable. This natural expected fluctuation is called common cause variation. It's the everyday noise in the system, the inherent variability that's always present. But if you suddenly swerve way off the path, that's special cause variation. Something unusual has influenced your ride. A data point outside the control limits is a sign something unusual happened. It indicates that a factor outside the normal process variation is at play. Control charts help you spot the difference between common cause and special cause variation, so you don't overreact to every little wobble, every minor fluctuation that's just part of the normal process. Over-adjusting, constantly tweaking the process in response to normal variation can actually make things worse, introducing instability where there was none. Control charts provide a clear data-driven basis to tell you when to act, addressing special causes, and when to let things be, allowing the process to run within its natural limits. They're more than just simple graphs. They're powerful scientific tools for informed decision-making, providing insights that can lead to significant improvements. By plotting your data points on the chart within statistically calculated control limits, you gain a visual representation of process behavior. This allows you to see the true rhythm of your process, understanding its natural flow and identifying any disruptions. Control charts effectively separate the signal, the meaningful changes, from the noise, the random variation, giving you deep insight into the stability of your process and its overall performance over time. They're an essential tool for anyone who wants to improve how things are done, optimize processes, and achieve consistent, reliable results. That's the power of science in action, providing a data-driven approach to understanding and improving the world around us. So, let's dive in and see how these control charts work in real-life scenarios, transforming raw data into actionable insights. Simple control charts are a fantastic starting point for understanding process behavior. They provide a basic framework for monitoring stability and identifying potential issues. These charts are often used to track key metrics and ensure that processes are operating within acceptable limits. They offer a visual representation of data, making it easier to spot trends and patterns. But real-world data isn't always simple. In fact, it's often messy, complex, and full of nuances that basic charts can't handle. Manufacturing processes, for example, generate vast amounts of data with varying characteristics. This data can be influenced by numerous factors, making it challenging to analyze using simple methods. Sometimes you're measuring things, like the diameter of a machined part or the temperature of a chemical reaction. These measurements are continuous data, meaning they can take on any value within a certain range. Other times, you're counting defects or errors, such as the number of scratches on a surface or the number of incorrect entries in a database. This is discrete data, which can only take on whole number values. That's where advanced control charts come in. They provide the necessary tools to analyze these different types of data effectively. They offer a more sophisticated approach to process monitoring and control, specialized tools for different data types. They are designed to handle the complexities of real-world data and provide accurate insights into process performance. Think of them as a full set of tools, each designed for a specific purpose. Having the right tool for the job is crucial for achieving accurate and reliable results. You wouldn't use a hammer for a screw. Using the wrong tool can lead to inaccurate results and potentially damage the process you're trying to control. For example, counting defective light bulbs, which is attribute data, requires a different chart than measuring screw length, which is variable data. Advanced charts like the P-chart, which is specifically designed for analyzing proportions or percentages of defective items, or C-chart, used for counting the number of defects per unit, use the right formulas for your data. These formulas are based on statistical principles that ensure accurate and reliable results. Using the right chart gives you a true picture of your process, allowing you to make informed decisions and take appropriate actions. Whether you're tracking infection rates in a hospital or counting customer complaints in a service center, there's a chart for you. Each chart is designed to provide specific insights into the data being analyzed. Advanced control charts let you tackle a wider range of data analysis scenarios of problems with precision, leading to more effective process control and improvement. It's all about taking your understanding to the next level, equipping you with the tools and knowledge to make data-driven decisions and achieve superior results. Meet your advanced control chart team, X-bar and R-chart. For measuring continuous data in small groups, tracks averages and variation. X-bar and S-chart for larger groups uses standard deviation for a more accurate look at variation. I-Mr chart for individual measurements tracks each value and the difference between consecutive points. P-chart tracks the percentage of defective items when sample sizes vary. NP-chart tracks the number of defective items when sample sizes are constant. C-chart counts the number of defects per unit when the area of opportunity is constant. U-chart tracks defects per unit when the area of opportunity changes. Each chart is designed for a specific type of data and situation. Using the right one helps you see what's really happening. Let's learn how to pick the perfect chart. Choosing the right control chart is simple if you follow a logical path. First, are you measuring continuous data or counting attribute data? For continuous data, if you collect in small groups, use X-bar and R. For larger groups, use X-bar and S. For single measurements, use I-Mr for attribute data. Are you counting defective items or individual defects? If defective items, use NP-chart for constant sample size, P-chart if it varies. If counting defects, use C-chart if the area is constant, U-chart if it changes. This decision tree ensures you always pick the right chart. The right chart means accurate analysis and better decisions. Don't guess, let your data guide you. With practice, this becomes second nature. Now let's see what your chart is telling you. Now you've got your chart. How do you read it? Points outside control limits are obvious signals, but patterns matter too. Watch for 2 out of 3 points near a control limit. This hints at a shift. Trends, 6 or more points rising or falling, suggest gradual change. Runs, 8 or more points on one side of the center line, mean the average has shifted. These patterns are early warnings, letting you fix problems before they grow. Too little variation or sawtooth patterns also tell a story. Learning to spot these clues is like reading the weather. Anticipate issues before they hit. The better you read your chart, the better you control your process. Let's see what to do when things go out of control. If your chart signals a problem, you got special cause variation. Your job? Investigate and find the root cause. It could be a machine malfunction, a change in materials, or operator error. Environmental changes, like temperature or humidity, can also trigger signals. Even faulty measurement tools can cause issues. Don't just adjust and move on. Dig deeper. Form a team, check logs, ask what changed at that moment. Solving the root cause makes your process stronger and more reliable. This is real-world problem-solving in action. Now let's talk about tools that make this easier. Drawing control charts by hand is history. Software does the heavy lifting now. Programs like Minitab and JMP make creating and analyzing charts fast and accurate. Minitab is an industry favorite. JMP is great for visual exploration. If you like coding, R and Python have powerful libraries for custom charts. Even Excel can handle basic control charts with a bit of setup. Software automates the math, so you can focus on interpreting results. Choose the tool that fits your needs and skill level. Let's wrap up with how to make your processes truly awesome. We've explored how control charts reveal the hidden life of your process. They help you separate normal variation from real problems, so you can focus your efforts. Choosing the right chart ensures your analysis is accurate and your actions are effective. Be a data detective. Look for patterns, not just out-of-control points. Investigate signals, find root causes, and make improvements. It's a cycle monitor. Learn, improve. Start with any process. Collect data, chart it, and see what you discover. The more you use control charts, the more you'll understand and improve the world around you. You have the tools to make things better, more efficient, and more reliable. Now go chart your way to better processes.